Hi, everybody. I'm Zhang Chenhui, data science lead at Merico, a company that develops advanced program analysis and software development lifecycle management tools that are designed to provide users with software engineering, human resource and information resource management services, enabling clients to achieve data-driven, optimal development performance. I must warn you that compared to all the excellent presentations that have gone before, mine will be a bit dry. It's mostly about data processing, and please bear with me, but I promise it will be short, and it's the last for today. My topic today is community responsiveness studies with Apache DevLake. Here's the outline. So after a brief introduction to Apache DevLake, we'll delve into the data and look at several large organizations and their open source communities, focusing on issues and pull requests responsiveness, as well as contributor growth. But first things first, what's Apache DevLake and its relation to Merico, the company? Apache DevLake Incubating is an open source development data platform that ingests, analyzes, and visualizes the fragmented data from various DevOps tools, generating insights about engineering output, developer experience, community growth, and many other focus areas. In other words, it is a solution that enables you to extract, analyze, and display in nice-looking charts in one place all of your software development data, be it from GitHub, GitLab, Jenkins, Jira, Feishu, or whatever. So think of DevLake as a software development data lake. And Merico is the company behind DevLake. Well, at least before it donated the project to the Apache Foundation. Many of my colleagues still work on the incubating project, and they take great pride in that. The workflow is simple. You begin by installing DevLake with one of the many options provided, including Docker Compose, Kubernetes, or an easy-to-use Helm chart. The next step is to collect data from your DevOps tools of choice by way of DevLake's frontend or its API. I chose the API because it's more flexible. When you have hundreds of GitHub repositories to collect, the front end becomes a bit unwieldy, to tell the truth. This is not to say, however, that the API is preferable in general. In fact, if you have only a handful of projects to collect, which is, I think, what most DevLake users do in their day-to-day work, that is to collect private company or team-wide development data. If that's your use case, then the front end is a more convenient and intuitive interface. The collected data is automatically stored in a layered schema. Normally, the domain layer is all you need. It includes tables like teams, jobs, repos, issues, commits, pull requests, CI/CD tasks, etc., regardless of your specific DevOps tool. So you see, it's all sorted out by DevLake. You can immediately examine your project's healthiness by going to DevLake's Grafana webpage, where many common metrics are provided in pre-built dashboards with names like community experience, engineering throughput and cycle time, weekly bug retro, to name a few. Lastly, DevLake is open. You can always define your own custom metrics and dashboards using SQL. You can even extend DevLake's data source types by contributing a new plugin. The above introduction to DevLake comes nowhere near to giving a fair presentation of the product's capabilities, but I think it suffices to our purposes, which is to collect from GitHub the following development data. The scope of our organization is Alibaba, Tencent, Microsoft, Google, and Apache. So 2 Chinese tech corporations 2 American ones, and an open source foundation. We only look at projects having at least 10 stars, so projects with some significance. And we focus the time span on the last 3 years, that is from January 2020 onwards. To support the study on community responsiveness and contributor growth, we will look at data related to contributors, issues, pull requests, and their comments or reviews. But before we can actually calculate the metrics, there is the issue of robots. These are automatic scripts that do style checking, static analysis, etc. The rub is that they have a user's account. Should they be counted as real users, or should they be filtered out? I think that although bots generally add to a project's overall smooth going, they are sometimes even indispensable. They do not, in the end, reflect an individual's intentional actions to contribute or help each other. For example, comments emitted by automated bots do not indicate real development activity. They only distort our metrics, so bots need to be removed in our calculations. Did you know that among those 5 organizations, since October alone, about 20 to 30% of all pull requests and issue comments are raised or closed by robots. Many bots bear telltale names like Dependabot, Sonar Cloud, Bot, CLA Assistant, GitHub Actions, and such like. Some even have nice little bot tag attached, like this one, Height. See, Height here is a robot. It has a bot tag attached here, and it has a square-shaped avatar. And the non-bots like this one, they have a round-shaped avatar, but this is not important. The important thing is that there is no rule of name patterns or tags that are exhaustive to exclude all those robots. Exceptions abound. Some just prefer realistic names and no tags attached. Meet Mr. Brown Truck, this one here at the bottom. We can only tell that it is a robot by what he says. He said, hello, I am an automated bot and blah, blah, blah. But if you don't see this message, there's no way to tell. So as a result, our filter will be based on a combination of name patterns and abnormal behavior detection. Specifically, accounts containing robot, bot, testing, etc. will be removed. A user that has contributed to more than 10,000 repositories will also be removed. With the data ready and robots removed, we can finally approach the responsiveness results. We first take a look at the time to initial issue response. This metric has a chaos definition. It is the time lapse between the opening of an issue and the first response to the issue from another contributor in days. For each project, the mean is calculated of all the lapses ending in each month, in effect, performing an aggregation by month. Note that care has been taken to make the aggregation anchored at the response month rather than at the issue creation month, in order to avoid a bias against the relatively new issues. To see this, imagine we aggregate by the issue creation month instead, which is more common. Then you will see all the new issues will have shorter response times simply because they haven't been around long enough to incur long response times. That's the bias. Next, At the organization level, the monthly median is taken of all the projects belonging to the organization. To further reduce detail and reveal the salient features, a moving average of 5 months is applied. Otherwise, the curve would be too jittery. So you see the curve here. It is calculated after all the averaging and aggregating has taken place. From the resulting charts, we can see that the average issue response is in the order of 10 days, whereas the pull request response is much shorter, about 1/10 that. So it's only about 1 to 2 days on average. The charts also show that Tencent and Alibaba are generally slower to respond compared to their American counterparts. The good news is that they seem to be catching up this year. So I'm referring to this chart at the bottom. You can see that the blue line is Tencent. It's time to first pull request response is reducing from about more than 2 days in 2021 and to around 1 day, especially after 2022. So next slide, community growth. Next, we turn to community growth metrics, which correspond to the community growth focus area from CHAOS. The questions to be answered are: how many contributors are making their first contribution to a given project? And how many contributors have gone inactive over a specific period of time? Basically, the same aggregation and averaging treatments were applied as in the responsiveness study, with one exception. Users must experience a period of inactivity to be deemed inactive. So inherently, there will be a delay, say 3 months, in the leaving counts. From the charts, the first order approximation is that the average project sees only 6 people come and 6 people go every month. This came as a surprise to me. I thought that the number would be higher. But in reality, the average project only has 6 people come and go every month. And also Alibaba and Apache are quite similar in terms of community growth measures. They are slightly higher than the others. These are easily seen from these two charts. As promised, the presentation will not take long. That concludes my presentation. Thanks for your time.